Hey everybody, this is Larry. This is me going over bi-weekly contest 66 Q3 distinct points reachable after substring removal. Hit the like button and subscribe button, join me in Discord. Let me know what you think about this one. This one to me, honestly, I knew basically right away. Well, I mean, basically right away, but not right away because I just missed the K part. If K is constant, this is pretty straightforward. Initially, I thought there was a variable K, meaning that you could do any K. Which is a little bit trickier, but yeah. But given K, then you know it's all about the visualization. I think there are a couple of ways you can think about visualizing this, or a couple of ideas to visualize rather, not different ways. And I am going to bring up the drawing board now. And the key thing to note is that okay. So basically, you have a set of instructions. You know, let's just say this is the string of instructions, right? You have up, down, left, right, dot, 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 right? And you're trying to remove some subset of them, right? And so then now, what does that look like? That means that now, after removing some sub array of them, you have this, and then it goes on, right? I think the key thing to note is that there are two things. One is that what I was gonna say. The key thing to note is that it just keeps going on, right? So you have to kind of, for this one, given that it's a constant K, that means that to me already is an indication of, you could say a sliding window or whatever, maybe a different way of thinking about it with sweep line as well. But the idea is that you can test every possible K, right? Because you have this, let's just say, and then this, a little bit, you know, you have to test every K. And maybe you could do, like I said, sliding window. There are a couple of ways to do it. But the idea is that you could test every one of these because there are at most n of these, right? Of course, you can't do it naively because then that's n squared. But if you are able to do them in a quick incremental kind of way, and there is the sliding window because that, but that requires another math that we'll go over in a sec. But this is just the framework of me thinking about it, right? In the sense that if I can do a sliding window, then this should be good. And then the next part though is the proof of, well, what does it mean to take away a spot? Well, I think I think this is a two-dimensional problem, right? You go up, down, left, right. It is a little bit confusing for sure if you don't have to like experience and practice and the visualization in your head, right? But for stuff like that, especially when the dimensions are symmetric, meaning that you know the left-right dimension is the same as up-down, just kind of, you know, it's different, but there's no distinctiveness about it, right? In that case, or maybe even in other cases, just compress to one dimension. And what I mean by that is just pretend you have, you know, LR instead, only L and R, or of course you can also do up down, but same idea, right? And then now when you do it this way, then now you're trying to, you know, you pretend the problem is the same, which is that you're trying to remove subset of these. Well, then what happens? Well, you can also now think about this now as going left is -1, you have +1, -1, -1, dot, dot, dot. I'm going to figure it out. So then now you could, now the ending, right, the entire thing will give you some number, I don't know, X, right? And then now we're trying to find the blue part. It's going to be some other number, let's just say D for delta, crappy looking D. Then now, then X minus D is going to be equal to basically the steps that are without this, right? I'm not going to go over the proof, like a mathematical proof or whatever, but you could kind of work out the visualization, you know, feel free to pause and then just kind of play around with it. And I trust that you work it out. And then once you realize that, then now that you realize that this extends to two-dimension as well, right? Because now, or maybe it extends the wrong word, but you could kind of, what you might call it, like separate them into multiple dimensions. Because now, instead of L and R, you could just say up and down. Well, what's up and down? And we only look at, still in this right now, look only at the X dimension. Well, up and down is the same thing, which is maybe like a no-op, right? Maybe we'll just write n instead of up and down, and it's the same thing except for n is just 0, right, in that dimension, and this gives you the same idea. And then now, of course, the next step from that is that you could look up, down, and play around with it. I know I can explain it and play around with it in more detail, but I hope that you do your homework now and just kind of work with it, right? But you get the idea. So then now the idea is that, let's go back for a second, right? Then now, if you have something like this, now we have this sliding window idea, or either sliding window, or because then now this is length k to get from here to here. It is just equal to subtracting this chunk, chop it off, and then adding this chunk, right? I mean, this is basic, sliding window, and that should be good enough. And you can figure that out pretty quickly. You do it for X, you do it for Y, and then you just kind of combine them. And then, I think the other part of, the number of unique points, you could, because we have shown that this had most n unique things, you just put it in a set. You put it in a set because there are at most n things, you could dedupe them that way. It's pretty straightforward to dedupe, right? We'll go over the code now, but that's kind of all the ideas that you need for this problem. And I keep it pretty straightforward, and I actually do it together. And I actually lied about the sliding window. I mean, you can still do it with the sliding window, and maybe as an up-solve, depending on which way you do it the other way, right? Because basically, the other way that you can do it is with prefix sum. Not gonna go over the prefix sum idea for this video that much. There are a lot of prefix sum videos of mine even, right? But the idea here is that, okay, go back to the thing with the left and right with one dimension, then you could just remove the chunk in the middle. Well, you could calculate the value of that chunk in all one time with prefix sum. That's the whole idea, right? If you don't understand prefix sum, then you have to kind of understand it. But that's the idea, right? Just try to subtract out the chunk, and that's it. So going my code, that's basically what I did. I did prefix sum of X, prefix sum of Y. I wrote the lookup for up, down, left, right. I do, for each direction in the income string, I look up the dxdy, which is from here, right? And then I just do prefix sum of X, prefix sum of Y. And as I said, on the X dimension, for example, you have 0, 0, -1, and 1. And the same for the other, for the Y dimension. And then now I just declare a scene, so that we could dedupe. Remember, we dedupe by removing I plus, or from I to I plus k minus 1 inclusive, right? So that means that, yeah, I mean, this is just gating it. You probably could actually put it into here, but I always feel like I'm really bad at like subtracting k and then subtracting k plus 1 or something like that. If I write it this way, this is a little bit cleaner, and it doesn't, I mean, not cleaner, but just like less error prone for me, right? And then now dx, this is the chunk that's inside with the prefix sum, right? And this is the x component, the y component. And then the answer is just going to be the last component, which is everything to the end with no subtraction, subtracting the stuff in the middle on the x side and the y side, and the combination of them would determine a unique point. And then, yeah, we just return the length of the deduped solution. And that's it. What's the complexity here, right? It's just everything's linear time, linear space. We have linear x, linear y, linear, and that's it, right? Linear, and then a lookup. This is also linear, constant time, constant space per element. So linear time, linear space in total. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve a live in contest now. Leetcode sometimes is silly, but it seems like we're okay so far. How are we doing on time? We have 1 hour and 22 left. I mean, we're okay on time. All right. Distinct points reachable after substring remover. Okay, you have do up, down, left, right. They do up, down, left, right things. Choose one. You're also given an positive integer k, you must choose and remove one contiguous string, and then perform the okay. Of length k. Okay, I actually missed the fixed length part, so I was like trying to go through the combinatorial. No, I mean that with fixed k, that's easier because then now it's just sliding window ish. It's a prefix something. It's not that hard. Okay, fine. Just prefix x, prefix y, right? Let's say px2. Okay, and then now for so let's do up, down, left, right. So this part I guess doesn't matter, though commas or is symmetric. Okay. There's no barriers or anything, right? Okay, and now for D and S, we want to say look up with D. Oh, well, no, I mean that's why we don't need it, because basically it's just going to do. Okay. So then now substring length k, it is going to be okay, now I need a notebook. I mean I don't need it, but I always have to make sure a little bit. Okay, so we have the full thing. We want to remove this thing, so then we just get this part, we get this part, which is the end. So we only, okay, fine. Something like remove I to I plus k minus 1. All right. So which means that it is going to be the index at I plus k minus so dx is equal to px of I plus k, I think. I hope this is right. I mean, it's way easier to have to do off by 1. So I mean, I know the math is right, but I'm trying to make sure that I don't get off by 1. Okay, and then it's this minus px of I. Is it I or I? We remove I, but it's I plus 1, so then you remove I. I think this is this. Okay. Right. And of course, we just assume that if I plus k is length of px, then we just kind of, I'm just going to continue because it's free-ish, it's cheap, but it probably should break. Okay, so then now, oh yeah, we have a scene set, say, and then now it's going to be the last one. Is it minus or plus? No, it's minus. Plus doesn't make sense, right? 211. I mean, 211 seems like it's still very error proof or error down. I mean, this matches. Oh, this is empty. I was like, I don't get it, but okay. I mean, it doesn't mean anything that my code matches the thing, so we'll see. Okay, because it's just so easy. The examples are not very good with respect to like how full I think it is. So apparently I'm still ranked 2000. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.